All right. Thank you, everyone, for joining us for December 2022 BrainX Community Live event, the last one for us for this year. We have some very exciting speakers and very exciting talks lined up. But for those of you who are joining us for the first time, I want to tell you that we created this BrainX Community platform around 4 years ago with the idea of having a unifying platform for machine learning in healthcare for good. And that's a photograph from our very first session that we held locally. And now we have grown to be a 4,000 plus member strong international community with 2,000 members on just our LinkedIn group. We have lots of resources that I'll go through on our website, brainxai.org or brainxcommunity.com. And then, of course, we hold these lively live sessions over here, giving an opportunity for various members and others to share their scientific work. So you can go to our webpage where you'll find the update section, which has the latest and the greatest updates about the BrainX community itself and the resources. We have the connect section that features all the information about our monthly live sessions and more. And you can go to our BrainX community YouTube channel. Please subscribe that so that you can get all these recordings delivered right to your email inbox once they are uploaded. As I mentioned, we have a very active LinkedIn group where many have participated, especially throughout this year, sharing a lot of interesting scientific information, meeting opportunities, collaboration opportunities, and so much more. So please join our LinkedIn group too, which goes by the name of BrainX Community. We have our Learn section on our website, which has a list of curated articles representing the scholarly work of many. We cannot provide the articles directly ourselves, but the links are available through the website, and they're categorized with the filter option to look for your own specialty work. So if you're interested in cardiology, you could filter it by cardiology, or other healthcare specialties, you could do the same. And of course, the number of journals in this space have been growing. So you could filter it by journals or by books to read the latest literature represented in a book format. Of course, everybody is very excited to get hands-on open source data sets, and that's going to be the talk of one of our speakers, how to curate the data. This is the largest repository of links to open source data sets, so satisfy all your needs by going to the data section of our website, brainxcommunity.com, and you can again filter the data type by the healthcare specialty that you're looking for and get the link to that data set along with the related publication. We have our podcast series, which features the experts who are in this field, who have been working in AI in healthcare, and we want to learn from them. Many of us want to learn from them about how they got started, whether they are a clinician or they are a machine learning engineer or a data scientist, what they're working on currently, and what their vision for the future holds. So listen to these exciting talks available to you through your favorite podcast channel, and please subscribe us there. And meetings and conferences are back. They are back in person too. So if you want to connect in person, go to our meetings or conferences section on our website, and you'll find the upcoming ones that you can go and register directly through the links provided over there. And of course, every year we provide a year in review. This year has been equally exciting. And we have already started the work on building our 2022 year in review. If you want to learn about what happened in different healthcare specialties or the latest trends in publication, look at our BrainX community year in review under the BrainX exclusive section. It's there on ResearchGate, and you can learn about what's going on in the scholarly world. But what's impressive to me is that despite all this work related to AI and healthcare, it's pretty much cornered by a few countries and few groups. And the geotrends, this is a graph that is from one of our upcoming publications, it's still under review, shows that it's essentially a few countries or few continents that are dominating this work. And unfortunately, it's very limited in other places. But I think we will learn from our speakers today how they are breaking this important ceiling, how they are working in their different environments in developing countries, and whether it comes to critical care, which has a lot of data, or whether it is about doing research or providing us with telehealth perspective, we will learn from them how others can also do this in their own area and can collaborate. So with that, I am going to hand it over and welcome Jorge Salluh from Brazil to introduce himself and present his talk today.
Hi, Piyush. Thanks again for the invitation. It's a real pleasure to be here with you and to discuss this topic. I'm Jorge Salluh. I'm an intensivist from Rio de Janeiro, Brazil, and I've been working in critical care for almost 25 years now, but in the last 15 years, we've been working with large data sets, as I was one of the co-founders of EpiMed, which is a company that actually provides cloud-based quality improvement and benchmarking solution for critical care. And what I'm going to talk about today is how we use this data set in a national level to not only provide for the individual ICUs the ability to measure ICU performance and outcomes and try to improve quality of care, but how actually to embed data science in large national registries and large ICU databases and provide evidence of improving outcomes of patients, which ultimately is what we as physicians would like to achieve. So just here my conflict of interest, as I've already mentioned. I'm also a member, co-founder of the Brazilian Research Intensive Care Network and Logic, which is an international consortium for ICU benchmarking, both nonprofit organizations. I'm a member of the Critical Care Asia and Africa study group, which is quality improvement, funded by Wellcome Trust and Oxford University. So for those not familiar with the concept, what is an ICU registry? What are these? Long story short, this is a clinical quality registry. There are lots of registries throughout specialties, cardiology, oncology, surgery, etc. And that's also true for intensive care. And a national or a regional, because sometimes it's related to a region of a specific country, ICU registry is actually a large, prospectively, continuously enrolling database that continuously enroll patients. Every patient in every ICU, you have to share a common core data set. Some of them, such as ours, will have modules of different data sets that are optional for the ICUs to add on some specifics, either to generate information on case mix, resource use, or process of care. But in general, there's a common core data set for every ICU registry. And the major aims for an ICU registry is to generate data on case mix, resource use, and outcomes for the individual ICU. So given already some useful information value for this ICU, but also to a country or a region. And that will allow benchmarking, performance evaluation, and quality improvement projects to be implemented at a local level, but also at regional or national level. So why do we need these national registries? Because they've been around for quite a while. The first national registries that we know of are the ones from the UK and the Netherlands and Australia, New Zealand. There's almost 30 years that these registries have been implemented. All of them have similar approaches. That this means that they started as nonprofit organization that provided these data sets to ICUs that joined the national registries on a voluntary basis, and then they started growing locally and nationally. So why do we think we need this sort of tool to improve outcomes? So first of all, the national registries provide countrywide epidemiologic data. They can ensure fair and relevant comparisons through risk-adjusted benchmarking. They allow, and we have seen that in the pandemic, how important it is. They allow near real-time estimates of ICU supply and demand and occupation. So that's quite important thing for the day-to-day management of intensive care, but at a regional or national level, very important in times such as we've seen with the COVID-19 pandemic. And this, of course, if we have all this in place, this will generate a robust national database that will actually reflect what's going on in the ICUs, the case mix, the outcomes, the trends in resource use. It's an updated source of epidemiologic data, and of course can be translated to high quality research. It's reliable to monitor outbreaks, pandemics, what's going on in ICUs, and how resilient they are to cope with disasters or mass casualties. And of course, this is always a compass for quality and quality improvement in critical care. What happened in Brazil was that until 15 years ago, we didn't have an ICU registry, and then we started this initiative by providing to the ICUs this common core database. Our first version was already a cloud-based one, thinking that this would allow the local management, the near real-time reporting, but also the merging of data that would allow comparisons of outcomes and of ICU performance. So with a partnership with AMIB, which is the Brazilian Society of Intensive Care, we started this project in 2010. And you can see here that it started with already quite an interesting number of hospitals and ICU beds. We had something around 80 ICUs when we started, but it's been growing ever since. And this little hiccup here is the pandemic and the worst year of the pandemic, at least in Brazil, which was 2021. But here we have something close to 1,700 intensive care units and 24,000 ICU beds, which represents something close to 40% of the ICU beds in Brazil. Apart from generating information locally to the ICUs through a web portal, this also has the Brazilian ICUs project, which is an open access portal. You can just look for it, Google it, and it allows public reporting of all the ICU profiles, the case mix, and the outcomes. And we think that this is very important, not only for healthcare professionals and providers, but also to the society in general. And we have proven that this is true, unfortunately, during the 2 years of the pandemic. What does our data that we capture from this rich data source shows in terms of quality improvement? I'm going to show you here 3 studies that derived from this very large national registry data set. The Orchestra study, which is a multi-center process structure and outcome study of Brazilian ICUs. The RDSL database, which is a database from hospital network comprising 126 intensive care units in Brazil, and their COVID-19 initiative. And I'm going to show a little bit of the results for you. So the Orchestra study started in 2013 with 78 ICUs. So you see that this is one of the challenges of starting this type of projects. Of course, at this point, we had something like 200 ICUs in the project, but only 78 joined the research project, because the research is a project within the National Registry, and it is voluntary. It is something that you have to go through all the usual IRB process, et cetera, but still, we have grown from 78 to now more than 150 actually intensive care units, and we have more than 500,000 ICU admissions with common core data sets and lots of information, valuable information on clinical characteristics, also on structural process and outcomes of ICU patients, resource use, and targets from quality improvement that are either generating from the direct analysis or from the data science working of this data to improve patient risk assessment, but also to identify room for improvement for intensive care units. So I'm just going to show a little bit of the data that we have and what we have brought in terms of evidence to the Brazilian intensive care units. So this study here is a study where we actually were one of the first groups at this time to assess the relevance of frailty in general critical care patients. At this point, 2018, there were already some publications on surgical patients mostly, and also on hospitalized patients, not a lot of data in intensive care. And here we worked with 93 ICUs, 130,000 admissions, and we looked at what was the effect of frailty on ICU admission. And what we could see actually was that frail patients not only had higher mortality rates, but also higher resource use, and this at every level, but especially in terms of the use of mechanical ventilation, renal replacement therapy, vasopressors, and blood components. This was actually a little bit surprising because we expected that, although we figured at first that frailty would be associated with worse short-term outcomes, we thought that this would actually be, in terms of resource use, mostly for the frail patients, but with lower scoring. That being said, that we believe that the patients that were extremely frail would actually have more lighter care, as we can say, but that was not what we found. And that has important implications to end-of-life practices, to resource use in patients that we know have very poor short and long-term outcomes. We also evaluated in the orchestra study, this multi-center study that I mentioned to you, the aspects of process of care and how it was associated with ICU efficiency and also with mortality rates. And what we saw here in this study, evaluating 78 ICUs, 60,000 ICU admissions, was that for every type of patient, every strata of severity, the number of implemented protocols for sepsis, stroke, community-acquired pneumonia, cardiovascular disease, but also for the prevention of ICU-acquired complications were associated with reduced ICU mortality rates. And it was important that when they were jointly managed protocols, that being said, multi-professionally managed protocols, this was even more important. And all these ICUs, the ICUs that had more protocols implemented in blocks of 5 protocols for each ICU, were also the most efficient. That being said, the ones that had lower risk-adjusted lengths of stay. We evaluated through unsupervised machine learning analysis if we could clusterize the ICUs in terms of the resource use, the staffing patterns, and the outcomes. And what we saw actually is that when we had out ICUs that were better staffed with 24/7 intensivist coverage, dedicated pharmacists, but also nurses that had higher autonomy, and we created an autonomy score to measure this. And this autonomy was actually to manage these protocols at bedside. These were the ICUs, or the cluster of ICUs, with lower mortality rates, but also with shorter ICU lengths of stay and shorter duration of mechanical ventilation. So here, not only an evidence that by using AI, we can improve the assessment of quality of care, but also that we can identify targets for improvement for intensive care units in large data sets. So this were a couple of the lessons from this orchestra study, sorry. Looking at the RDSL cohort, which is also a subset of the national registry, 126 ICUs, currently more than 700,000 ICU admissions in this data set. We also looked at this specific cohort to try to identify targets for quality improvement and to use data science to improve risk prediction. So some of the things that we looked, here is a study specifically looking at cancer patients, and we have evaluated and done also simulations to try to understand what was happening in terms of outcomes of cancer patients requiring unplanned ICU admission. And what we saw here was that the trends showed that there were actually reductions in mortality rates and lengths of stay over time, although the numbers of admissions were increasing for almost every type of cancer. Nevertheless, when we clusterized for some characteristics, types of cancer, previous functional performance status, and also resource use, what we saw was that there were most clusters were associated with improved survival. However, there were clusters that still remained with poor outcomes, such as patients with lung cancer with multi-organ failure, or patients with any advanced cancer but very compromised performance status before hospital admission. So this was also a way to look at a specific subset of patients to try to understand their outcomes. We advanced a little bit more in terms of using AI, and this study published only recently this year, we evaluated prediction models for hospital lengths of stay and 30-day mortality in patients with stroke. Stroke is relevant anywhere, but in Brazil specifically because it remains a high source of morbidity and mortality in the population, specifically in the public hospitals. So we analyze here 17,000 ICU admissions, and we have actually been able to derive a quite accurate model, and the random forest and the boosting were the ones with the best performance to predict 30-day mortality and lengths of stay for these very severe patients. We have been trying to work on ways also to improve the assessment of ICU efficiency. So this recently published study, we evaluated almost 100,000 ICU admissions in more than 100 ICUs in Brazil. And what we have tried to do was to use early baseline characteristics on the first day of ICU admissions to try to predict ICU length of stay. You can see here that the prediction was quite good, and specifically with the XG boosting models, but not only useful for the individual prediction of ICU stay, but also to try to benchmark intensive care units according to risk-adjusted lengths of stay. So another way that we use the national data to try to advance the knowledge on this. And this is just a little bit of a summary of what I mentioned before. And finally, during the pandemic, we used in the same network the real-time data to try to monitor, and this is data from 2020, the patient influx, the number of admissions. We saw that peaking admissions were associated with not only, of course, number of deaths, but the mortality rates, meaning that the surges were stressing the systems. But we also found the bright side here. So we monitored also resource use. And very early on in the pandemic, we showed that using non-invasive respiratory support as a first approach was efficient and reducing mortality rates in a risk-adjusted way, when even adjusting for severity of illness, PaO2, FiO2, comorbidities, age, and frailty. We showed that this was actually important for the patient. So we were continuously monitoring data and giving feedback to the users to try to improve the information that was being used to support the clinical decision. But we also saw that the traditional way that we were evaluating the ICU outcomes and the ICU efficiency before the pandemic, as with SAPS-3 scores, for instance, was not good enough with for the COVID-19 patients. We tried to recalibrate for this model, but unfortunately, it did not improve so much. So we looked for other ways to try to assess ICU efficiency in these patients. I'm going to move a little bit quicker here. And finally, we also use this information to try to predict resource use, because resource constraints were constant during the pandemic. And here is just a little bit of information of this paper, which is to be published soon. 13,000 ICU patients with COVID-19 needing and respiratory failure. And what we did was to use also a machine learning approach to try to derive a predictive model to predict those patients that would require renal replacement therapy. We used baseline variables, just first day variables, easily available information, not very much granular data, which means this is replicable in most intensive care units. And actually, we had a pretty good model that identified patients at risk for severe acute kidney injury and the need for renal replacement therapy. So in conclusion, the ICU registries and data science initiatives such as ours actually help to improve understanding of case mix, resource use, and outcomes, and are feasible in low and middle income countries. Brazil is a very large 200 million population middle income country with all the heterogeneity that you can imagine, but still we proved that this is possible and that these large databases can provide insights and targets to improve delivery of care. There are several new frontiers to the use of data to improve outcomes and ICU efficiency, but I'm sure that only through collaborative research, we are going to give the next step. So thank you.
Thank you, Dr. Salluh. That was amazing, some amazing work, and not just about constructing that database, but also making it meaningful and utilizing that in some very meaningful way in a short period of time. That congratulations to you and your team. I have a question about the cloud architecture because I feel that still there is a lot of concern, and many people feel little insecure, even in US, in putting the data on to cloud. So, what approach did you or your team take about that?
Thanks for the comments and the question, Piyush. So we started 15 years ago. So even the term cloud was not there yet, right? We would say something else like online, web-based, internet, something like this. But so you can imagine that it was very hard in the beginning. And also when we started, there were no specific regulations apart from the regulations of using medical data, but not specific regulations for the health cloud. So what we have done in the beginning was to try to build our own model of what we felt was the higher end security. We based this a lot 15 years or 10 years ago on the finance system, what other people were doing, dealing with sensitive data where everyone's worried about. And we try to make it also very transparent to the hospitals. We put this in a contract, so we assumed all the risk and the liability of it, but we knew that we were doing the best in terms of the technology at that point. So that helped us build the trust. We also guaranteed that although people could benchmark, this benchmark would not be identifying ICUs. I would compare my ICUs, and our AI cloud would say, this cluster of ICUs look like your ICU because of several characteristics, so you should compare with this cluster of 100, 250, 500 ICUs that we selected here based on patient characteristics, etc. So we try to make it to respect not only the regulations and confidentiality. That helped us also because when more recent regulations like HIPAA compliance, our GDPR, European regulations, all stuff that were somehow adapted and implemented in Brazil, we were very close to it. So we had to make few adaptations. But also, time was on our side because lots of people were already using it, and that built a sense of community and trust.
That's great. What about making it open source and available to other communities? We have seen the work that has gone on with Mimic and the Amsterdam ICU. I think of all the communities, the critical care community is blessed to have some very curated, well-designed data sets that are available and promoting research. And also comparing the outcomes, not just between different countries, but some of the validation methods that you have used across different data set and the users.
Great question. So to address your 3 points, the first one, so that was the downside of all the rigid contracts that we made in the beginning to make it feasible for people to join, trust, etc. We cannot share the anonymized data set, but within the research projects, which are a cohort, a subset of the largest cohort, we can. So what we do today is that we have a steering committee for the research project. People can just send and apply to use the data in research projects. So it's not fully open, but it has a door which is people can use for it. The second aspect related to being able to compare and validate data. So for validation, also through the research cohort, that's possible. We've done some work with the Dutch, with also the Critical Care Asia project. So this is something feasible. And finally, in terms of the international, we have this Logic project, which is the linking of global intensive care. It's now already 18 countries that have ICU national registries such as ours. I was one of the founders of this project together with other researchers from other countries. And now we are doing a lot of work on research, comparing outcomes and resource use in different health systems. And everyone is free to look at the data. I will just put the websites here on our chat so you can access it. And please feel free to email me afterwards.
That's great. I'm going to take the last question over here for you. And this is from Abhijit Anand. He's asking if you can talk about the data entry process. Like, is that automated? Is there a data entry operator? How are you solving that problem
Excellent
of
question.
data entry?
Excellent and crucial question, actually. So again, because we started 15 years ago, even the term interoperability was not there fully, right? So we had to start with something which would be compatible for most hospitals. So the first hospitals 15 or 10 years ago were hospitals working with a hybrid model where we would connect with administrative data and most clinical data would be entered manually. We progressed through different interoperability systems according to the time, of course, as you can imagine, to add lab, EMR, etc. But still today, because the degree of adoption of EMRs is very heterogeneous in Brazil, we have hospitals that are almost fully manual and hospitals that are fully automated in terms of capturing data from EMR and other sources that are available in the hospital.
That's great. Well, unfortunately, Brazil didn't win the World Cup, but your work surely is a World Cup winner. So thank you for spearheading that and all the amazing work. I'm sure there will be many collaboration opportunities that will come your way. We look forward to that. With that, I'm going to move over to the two Dileeps from India, invite them to talk about their amazing work and give their perspective from a very different developing country, again, in the field of critical care. And they are the amazing founders of this amazing company called Cloudphysician. So Dileep, I'll welcome you and please introduce yourself and talk to us about your amazing work here. Thank you.
Thanks, Piyush, and Jorge, thank you for your talk as well. It was quite enlightening and very heartening to see data come out and research come out in this specialty in not so easy to work settings. So that I think is a theme that we resonate well with today. So I'll just share my screen and will introduce myself and the team. So at Cloudphysician, we're a company based out of India, and what we do is we provide remote critical care, similar to most tele-ICU networks. But how we are different is that the use case and the approach to our tele-ICU services is a little different here. So much to say that our entire business model and functional model in India is geared towards how we can provide services to resource-constrained hospitals that do not have the IT stack or the software stack that is fairly prevalent in North America that allows tele-ICU or remote services to be deployed. So the constraint here is very different, and that is how we've operated here for the last 5 years or so. We're coming up to 6 years. My background is in critical care, pulmonary and critical care. I trained at the Cleveland Clinic. And me and my co-founder's name is Dhruv Joshi, he's also on the call. We moved back to India to start this because the problem statement was obviously evident. There were too few critical care specialists in India. 95% of Indian ICUs are not staffed by an intensivist. And that's a pretty telling and stark statement about the state of critical care in the country. And that is a problem that needed to be solved. And so we set up our operations framework. We cover about 18 states of India. That's about 500 beds or so across the country, across not just difficult terrains, but also operational landscapes. And to do that, we had to develop our own tech stack because legacy players, technology players would not function the same way that they would function in the US. A cut, copy, paste of that just wouldn't work in India. So we had to do this from scratch. And what we realized was that we would have to use software, machine learning tools in a very utilitarian way. We would have to be very precise with what we developed in-house. because tools that we needed just didn't exist in the market in the way we wanted them to. And what we also realized was that the team needed to be made of clinicians and technologists who understood healthcare really well. So the other Dileep here, in case you're wondering, is our technology lead. He is an internal medicine doctor, also did his residency in the US, and then moved back to essentially move over to the dark side and do our entire data science landscape. He takes care of everything that's related to any ML tool that we build, along with the rest of the technology team. So the reason why I mentioned that is some of the insights that you will see are very practical and pragmatic towards what we needed to do in the Indian landscape. And one of the questions really hit home. One of them asked, how do you get the data from some of these settings? And that was precisely the problem that we continue to have and continue to solve with different innovative ways. So we'll share that with you shortly, and that's sort of the introduction here. I obviously have a disclaimer. I founded the company with Dhruv, and I'm a director and a board member. This healthcare iron triangle is frequently talked about, and we often use this to demonstrate the problem statement in India and largely to the rest of the developing world as well. You cannot solve for quality, access, and cost all at the same time in a typical traditional environment. If you increase quality, for example, invariably you reduce access and increase cost. And you can play the same sort of arrangement with different aspects of the triangle, which essentially reduces the likelihood of equitable healthcare that is based on values and gives the desired outcome for patients in hard to reach areas. So obviously, everybody in this call understands that perhaps technology is one way to break this iron triangle. And almost all the time in healthcare, you have to couple technology along with service to do this. And this is what we are familiar with in the US, for example, where you have lots of systems, perhaps integrated to a certain degree on modern EMRs or electronic medical records. But this is certainly not the case in the Indian landscape, because these systems really do not talk to each other. And the struggle that we have, not just at Cloudphysician, but also other providers in the space, is that how do we use newer frameworks to reduce the barrier to that provider that's in a remote part of the country to receive services that are directly impactful towards the patient that they are treating at the bedside. Like I said, 9 out of 10 ICUs in India do not have access to this expertise. But the remote doctor needs to have all of the data that they would need to help the patient. So that is the challenge that we are looking at. And again, our approach to the tools we built are based off this requirement. So necessity is the mother of invention, and that is a problem statement that we were faced with. So I'll hand it off to Dileep Unnikrishnan, DU, as we call him, to avoid name confusion. DU can probably just talk about some of these journeys that that we look at, both from a patient standpoint, but also from a provider standpoint, and share maybe 2 or 3 tools that we developed in-house to solve some of these problems. And then we'll go on to where we think this is going for the developing world, which is most of the world right now that is in need of critical care in hard to reach areas. DU, over to you.
Thanks, Dileep. So yeah, like I'll share the data journey that we have been through over the last 4 to 5 years. So see, this is the just like any other company, like the data journey involves 4 different phases, which would be like the collection, storage, leveraging, and finally to the place that we all want to be, the making the clinical impact at the bedside, right? So in general, as a smart ICU solution providing mostly to the low and middle income countries, the hardest part for us was mostly in the left side of the journey, which is the data collection part. Like, it's very hard to get the data out of the pen and paper into an electronic form, and that's where our focus has been mostly so far. And like while you look at any Western ICUs, like the data is already there, and the most of the focus goes on to the leveraging and making of the clinical impact part. So can you go to the next slide? Yeah. When we started our journey, like we looked at the different data points that we have to capture in order to have a full clinical picture of the patient. And these mainly fall into two major categories. One is the provider generated data, and the other would be the device and software generated data. The provider generated data would be your, the notes written by the doctors and nurses, the vitals entered by the data entry people, the lab reports that have to be entered. So these are the provider generated data. And there were several things that we had to tackle to capture these data points. Like few of them would be like the barriers to adoption, like I'm not very good at typing, so how do I type a full note for this patient every single day? So we had to tackle that using smart tools and better design of the whole platform. And then questions about the incentives, like okay, I'll spend 15 minutes, 13 minutes doing this for you, like entering this in the digital format, but what's in it for me? So we had to incentivize good behavior, like if I spend 15 minutes extra typing this note, I'll get so and so clinical decision support tool, or my overall work is going to reduce at the another phase. Like those sort of incentivizing had to be done. Then the second part, the device and software generated data, that's I think a little bit unique to the healthcare domain. If you walk into any ICUs, like you'll see many machines assisting in the patient care, and many software assisting in the patient care. Like you have your cardiac monitors, ventilators, different kinds of EMRs, LICS. So all these have to talk to each other, or to a common platform for the smooth flow of the patient care. This unfortunately this ideally has to happen through an API, application programming interface, which talks a common language like FHIR or HL7. But unfortunately, that's not the case in the real world, at least in the low and middle income countries. Like either the devices or the software doesn't provide the API at all, or the hospital has to pay extra to get those services, which most of these hospitals won't be willing to do. So we had to make some hacky solutions to capture those data points, which I'll be talking about in the coming slides. Next slide, please. Okay, so first I'll talk about some solutions that we created for accessing the provider generated data. So this is basically what these tools are doing is to reduce the effort it takes for the provider to enter the data in a digital format. So one of the major data rich item in an ICU is the doctor and the patient, the doctor or the nurse written note. So we had to capture this data point. So these are the two tools that we created to do this. IRA is a natural language generation tool, which parses the patient data in the EMR and uses a set of rule-based and ML-based algorithms to generate a naturally sounding templated note on which the provider can either type on further to add more data, or he can use this Swara, which is optimized for Indian accent and medical terminology. So they just can dictate their notes onto this templated note. So these two tools has been a major success for us in increasing the adoption of our of the platform. And we have been able to reduce the effort it takes and time it takes to write a note. Next slide, please. The second major time sink, especially for the nurses and the data entry associates in an ICU, is transcribing the reports, the lab and imaging reports into a digital format. So, most of our partner ICUs, they don't have a LICS in place. So most of the reports that's generated is mostly like a piece of paper with all the lab values printed on it, and this has to be somehow digitized for us to use that in a meaningful fashion, right? So this is what we came up with. We call it HERA. It's a OCR based tool with which the bedside provider just has to snap an image of the report, and it's passed on to an OCR algorithm, optical character recognition algorithm, and it captures all the data in a digital format and is entered into Radar. Radar is the platform, the name of our platform, into Radar, and for the user to review. And once reviewed, it's submitted for the to go into the digital record. Next slide, please. Yeah, so this is accessing the machine generated data. So this is like I said, the ideal way for this is through APIs, which is never the case. So we had to come up with an elaborate architecture that we call as Netra in here. So we have high definition cameras installed in all our partner ICUs. So we program these cameras to capture images of these monitors, the ventilator monitor, the cardiac monitor, urine bags, at a regular interval, like either every 1 hour, every 30 minutes, every 4 hours. So these captured images are then transmitted through a set of proprietary algorithms that we have patented. And it identifies the information inside the image with context. So for example, in this particular image, the 71 is not just recognized as the number 71, it's also recognized as the patient's heart rate and is entered into Radar in a digital format. So this also has helped to drastically reduce the effort it takes for the bedside nurses to monitor and transcribe the information generated. Yeah. Next slide, please. Yeah. So this is another piece a piece of the puzzle, which is dealing with the legacy EMR systems that's already in place. So a few of the ICUs that we partner with already have legacy EMRs in place in wards or OB, or even in the ICU. So whenever a patient comes into our system, getting access to all this data that's already entered in the other EMR, that was a major problem and a major time sink for either the bedside team or for our team. So essentially what we did here was to create a set of web crawlers that crawls through these EMRs, goes and downloads the relevant information either as PDF or CSV or whichever format, or even JPEGs, and then pass it digitize it through a set of algorithms and enter that into our ICU solution, Radar. So and this is robotic process or automation, RPA. This is essentially an RPA tool. Next slide, please. Okay, that's with the collection part. The storing part, I'm not going to go into a lot of details as this is mostly technical and pretty straightforward. The only point that I'm going to make here is that we have one of the largest ICU, or the largest ICU repository from India. We have over 52,000 unique the data from over 52,000 unique ICU admissions, and this is all stored in a clean, succinct, and retrievable format, very similar to the Mimic database. And this repository is growing day by day. Next slide, please. And the third part and the most important part is leveraging. So data at hand can be leveraged in a million different ways. And you have to be very careful in the questions and the problems that you select to be solved. So the three major problems that we optimize our data leveraging and the creation of our data solutions is like whether the solution improves patient care, whether the solution reduces the provider effort so that they can spend more time with the patient and less time with the computer, and the thirdly, whether the solution increases the adoptions so that more providers can come in into the platform and provide care for more patients. Next slide, please. Yeah, and this is the data solutions broadly can be divided into descriptive, predictive, and prescriptive. And it often amazes me how much value can be provided just with descriptive solutions, data solutions, like a dashboard that shows mortality with the Apache score, the trends in mortality versus Apache score. So even such solutions, simple solutions, can help the bedside providers to look at the performance, like they bring in an intervention in their ICU, and did that affect the mortality, like has the Apache score been trending up while the mortality coming down. Those sort of even simple solutions provide a lot of value. Next slide, please. And lastly, I'll just touch upon one of the data solutions that we are really excited about in releasing in the next few months. That is the predicting the clinical deterioration. So using the techniques that I mentioned in the last few slides, we have been able to capture a lot of patient data points, like the diagnosis of the patient, the lab results, medication, the notes written by the doctors and nurses at different time points in the patient's journey through over time in the ICU. So we are developing a clinical deterioration index based on LSTM, long short-term memory, and EBM algorithms, like explainable booster machine algorithms. So this has been shown to have shown to be very effective in predicting the clinical deterioration of the patient in the next 24 hours based on the data points in a fixed time window before, like either 6 hours or 12 hours data points. So this is in the early phases, and we'll be releasing, like doing the pilot runs of these algorithms in the next few months, coming few months. So yeah, with that, I'll pass it back to you.
So yeah, thanks a lot, Dileep. See, one of the things that we are looking as a continuing theme here is that how do we figure out the challenges that we are facing in our area, and that's really access to data first before we can even do anything else that is going to be impactful. And everything you saw seems like a roundabout way to getting the data, but if the basic infrastructure to give you the data does not exist, waiting for that is essentially an economic decision for the hospitals that we deal with. So for example, they will have to invest lots of money in setting up the entire infra to enhance the ability of their hospital to give us that data. And that would mean 2, 5, maybe even 10 years of delay before even you can get the data from these hospitals to allow some tools to be built. And that's where we're at. So when we were looking at this, I was reminded of this paper that I read in 2014, where we essentially were reading this paper just before we graduated from a fellowship on how to set up a smart ICU. This was the standard framework. This is a connected ecosystem that they proposed. And interestingly, just once we came back to India and we looked at newer devices and things that were available, it was almost like deja vu. Just like India skipped the pager generation and went straight from wired phones to cell phones, I think there's probably newer ways to do this. And having explored the technology and the IT landscape, we're looking at computer vision, robotic process automation, like Dileep talked about, where you can integrate legacy EMRs without the legacy tools that are potentially very expensive and simply hard to unravel for any small hospital. Most of these small hospitals don't even have an IT team. So you're going to have to be the ICU in the box for them using these newer tools to extract that data without any support from the bedside whatsoever. That's the challenge that we had. So looking at QR codes, computer vision, machine learning using optical character recognition, finding out any way to actually extract the data ended up helping our use case towards this march towards utilitarianism. To really sum that up, what we think should be key in the medical world, we're in critical care, but I think this applies to most areas, is that we really need to identify the stakeholders first, because it's easy to say that, hey, we have a machine learning tool, gradient boost, or whatever we see as a signal, and then try to find a problem. Whereas the approach we are looking at is, let's just look at the problem directly, look at the stakeholders, and pair the outcome and the action right at the get-go. Once you do that pairing, then you figure out, what sort of number do you need that needs to benefit from this pairing, both from an outcomes perspective and even a machine learning perspective. And then we happen to go to the field and figure out how this data will actually be available at a certain quality to allow this model or this tool to be built. Only then can we even hope of any clinical uptake and evaluation with feedback loops, using quality initiatives and frameworks to evaluate the tool real time. I think Dr. Chelly had some interesting work in a recent paper where this model of constantly upgrading the tool as it plays in the field is critical. And most tools actually do not receive upgrades once they're developed and tested. So that is something that we are very careful about, because this landscape is rapidly changing. The data that we have is from low to middle sized hospitals in India, which is extremely hard to reach. And we're already careful that the data from larger cities in India may be quite a bit different. So we just need to be careful as to how our utility and feasibility evolve as our clinical services continues to mature across the country. And similar papers are pushing across a similar theme, where true AI may actually be some distance away. And perhaps really the most important utility that we can pass on to the bedside is simply augmenting what they have. And for that, all you need is a tool that just makes the day-to-day of a doctor or a nurse that much easier. AI to AI is how we think about it. And perhaps that is one way to look at how the business case itself can be modeled apart from AI or machine learning modeling. So I think we want to gravitate towards a smart ICU that is not just a patient care platform, but also a collaboration platform, whether it is collaboration for research or analytics, or collaboration for multidisciplinary care with care teams from both sides of the care landscape, which is one is the bedside and one is the remote one. And I think the term EAR, EMR, or EHR itself may need to be retired to something that is more wholesome, which we would call a healthcare experience platform that has the best features of these things that we talked about. Because at the end of the day, I think focusing on patient and provider experience is what is going to deliver better care tomorrow. With that, I'll stop. I just wanted to put these things together. Thank you, Piyush, for this opportunity. And this is just a really great group of like-minded individuals. And I think the future is bright. So hope to interact as much as possible down the line.
No, thank you, Dileep, or rather I should say Dileep, both of you, a phenomenal job, constructing these solutions understanding the local challenges very well, and designing these. I can tell you, in my own experience, we have Teradata as our data mart, you can say, or our data warehouse. We have all these tools in Epic and other things. We still struggle extracting data from that, and I think you have solved your local problem in a very innovative way. So that's a great highlight, and congratulations on that. And I think some of the solutions to me made me think, like, were you guys ahead of ChatGPT? Because trying to generate or translate some of the information from clinical notes, it sounds like it summarizes it very well, maybe even better than ChatGPT, which may not understand the medical language as well. So you have to design specific solutions for healthcare, as many of these general tools that are out there using natural language may not directly conform to our language. But one of the questions I had was about standardizing it, because as you said, like a lot of hospitals that you work at are smaller hospitals. They all might have different setups. So when you showed the picture of that monitor, it made me wonder, well, okay, the heart rate in one might be displayed on the top, the other one, it might be at the bottom, and you're using like a camera to capture that. And one, it might be green color, the other one, it might be blue in color, whichever way they are set up. How did you approach standardization? Did you ask the hospitals to standardize it, or did you make your tools smart enough that they can infer that?
That's a really good question. I'll leave the ICD-10 question for Dileep, because DU, the other Dileep, because he is actively working on that a little bit with a different sort of a framework. But this question that you asked is very interesting. We did face these problems, but we went back to how you and I would interpret it if we were at the bedside. So just like you guessed, we put all the cues together: spatial, color, direction, and just a few rules to allow it to learn in a supervised manner. We didn't take the deep learning brute force approach. We actually took the supervised approach, where we did color matching, we did pixel matching. In fact, we put really easy rules that if it is more than 100, it cannot be saturation. So then that way you, for example, excluded one cell and you were able to map it to the others. So initially it would take maybe 6 weeks or so for us to train it on one monitor type. Now we can go live in as little as 6 days or so, with a little bit of tweaking when we encounter a new hospital. So it includes all of the above that you talked about: color, shape of the graph, and ECG looks a little different from a pulse ox, for example, the rate at which it's going. And we also do it by association, right? Sometimes when the clinician is looking at it, they look at the heart rate, and then they see the heart rate from the pulse ox right below. So then there is a confidence level on the algorithm that goes up when it actually sees these numbers in association. So yeah, it took some time to do that, but the goal is that we want to replicate this in ventilators as well. So that is something that we are actively working on, where we can take the same tool that now exists and extrapolate it to the ventilator. Of course, it's not as good as streaming data every 20 milliseconds like we have in the US, but that is not the problem statement we are solving. We're trying to figure out if this is actually going to help the clinician. I don't think getting data every 2 seconds actually helps the clinician directly. Maybe someday it will, but at least not right now. So that's how we're breaking this down. Dileep, you want to take the ICD question from the group?
I'm sorry, what's
Dileep, the question, or the question was related to standardizing diagnosis codes, because I can see how how clinicians might write different diagnoses, but then you still need them in a standardized format. So whether you use ICD-10, translate those to ICD-10 or something, how do you approach approach that?
Yeah, we have had a very hard time with ICD-10 because it's not arranged in a very interpretable way. It's more for billing than for anything
That's right.
else. Yeah, so we have gone with SNOMED instead, because the SNOMED comes with a lot of fringe benefits. Like there is already a knowledge graph built in for SNOMED, which can be utilized. and it's arranged in a more intuitive fashion, and it has ICD only has diagnosis. SNOMED has much more than diagnosis. So SNOMED is our go-to tool for it. And with regards to standardizing the diagnosis, again, we have approached this in a very, very pragmatic and utilitarian perspective. So it doesn't matter if if it's a left anterior wall myocardial infarction, or left posterior wall myocardial infarction, when it comes to retrospective data analysis. So we have at least for now, we have focused it only to the broad diagnosis, just to give them an idea on, like, okay, over the last 6 months, what's the trend of the myocardial infarction admissions in this particular ICU? What's the trend of sepsis admissions in this particular ICU? Like, doesn't matter if it's an E. coli or salmonella sepsis. So, like, very broad and utilitarian aspect of it. Yeah.
That's great. Well, this was an amazing presentation. I learned a lot, and hopefully some of the developed countries can adopt some of these tools to develop like cost-effective solutions over here. We struggle to get vent waveform data too over here. And the challenge is like, it's the expense challenge, and then we just don't look for a solution. Rather, we should innovate some of these solutions in a cost-effective manner. So thank you both, and thank you for the wonderful work that Cloudphysician is doing. I wish we could go on with this forever, but this will end our December 2022 BrainX Community Live event and also close the year on a high. So thank you everyone for joining us. Thank you for participating in this. Until next time, take care and goodbye.
Thank you. Take care.